Okay, so day 2 of inverses. We are going to start solving today using the same inverses that we've been doing. In the meanwhile, I want you to do this for your bell ringer because some of you are still having issues recognizing how to write those equations for your project as far as what transformations have occurred and how you would write them for your weather data. So pause the video, take no more than 5 minutes, go ahead and write down all the transformations for these, and then unpause and we'll go over it. Okay, so transformations that have occurred. And by the way, this one has 3 and this one has 2. Okay, so let's take a look. Our normal sine function looks like this. Okay, but remember, we don't count a period change as a transformation. All that does is change the x-axis. If you want to say that it makes it, I don't know if it squishes it horizontally, but we don't actually call it that. So we're not worried about the period change. We're literally just looking at A and D. Okay, so in this case, our amplitude is a half, right? And it's negative, which means it's been reflected. Okay, and our midline is 5. Okay, y equals 5 specifically. So what does that all mean for the normal sine function? Okay, so it's been dilated by a half, so it's been made smaller. It's been flipped upside down, that's reflected, and it's been translated 5 up. It's been, the whole graph has been moved 5 units or 5 squares up on a graph. Okay, what you're doing for your weather data, okay, is, basically the same thing. You're translating you're transforming rather a regular sine or a regular cosine function. You're changing the midline, you're changing the amplitude, you might be reflecting it. Okay, so you're dilating and you're translating and you're reflecting, but you're doing all of that because the normal sine function, if it's the sine, looks like this. And if you plot your weather data, if it falls into that kind of a pattern, well, it's been, dilated and translated and all that other stuff. So let's take a look at the cosine one. Okay, so again, normal cosine function. Okay, and what's been done? Well, your amplitude is now 3, which means it's been dilated. It's 3 times as big. Okay, and your midline is y equals -7, which means it's been translated, the whole graph has been translated 7 down. All right, so let's take a look at what a normal cosine function looks like. Okay, that's your normal cosine function. And if your weather data looks like this, then it's a cosine function that's probably been dilated and translated. And this is the one that's catching a lot of you. If your weather data looks like this, that's also been reflected. Okay, so it's starting at the bottom and going up to the top. And that means that A has to be negative. That's the only way to make the cosine function do that. Okay, and yes, I know amplitude is never supposed to be negative, and you're right, because amplitude is how far the graph is stretched, but the only way to reflect it, to flip it over, is to make A negative. Okay, so base review on transformations, on to inverses for today. Okay, so yesterday we were doing inverses of functions where you're actually, solving for the inverse, swapping the x and y and doing all that, or doing this on a graph. We're going to use that same principle of using inverses to solve. Okay, so we're going to start with basic equations today. You won't have to do anything more than just basic equations. And then, okay, that was weird. And then, when we get back from the break, we'll do some that are a little bit harder, after we do a little bit of a review. Okay, so Sine x equals 1/2. Okay, we are solving for x. It's a normal equation. If we said 2x equals 12, we'd still be solving for the x. So we have to do the inverse of whatever's attached to the x. Okay, well, in this case, the inverse of sine is the little sign to the -1. So we need to multiply by that on both sides. Okay, and what it would look like when we do that, sine -1 times sine x equals basically sine -1 of 1/2. Okay, now this is not something you can put in your calculator because what we're trying to do is get the values off of your unit circles. Now, if you don't have your unit circles, you may want to pause the video and go get them. I did tell you specifically several times that it was in your best interest to make a set, you know, the ones that you had to turn in for homework with radians, degrees, and coordinates, to make a set for yourself because you were going to need them. Okay, so if we multiply by sine inverse on both sides, this cancels, and all you have left is x. All right, on this side, what you have is the sine inverse of 1/2. All right, so how do we actually figure out what that is? By using the unit circle. Well, we need to figure out what this actually means. Okay, this statement actually means something very, very specific. Okay, when we are taking the inverse sine or cosine of something, okay, which is what we did here, what you're actually doing is solving for the angle measure on the unit circle that gives this measurement. Okay, so what is this actually asking? It is asking for the sine measurement on the unit circle, or rather the angle measure on the unit circle that has a sine value of 1/2. Literally, where on your unit circle does sine equal 1/2? So the sine of what degree or what radian equals 1/2. Okay, so and again, this is why you're going to need your unit circle for this. Okay, so, you know, basic one. And by the way, there are actually two answers to this statement because there are two places on the unit circle where sine equals 1/2. And if you, again, remember the thing I did with unit circles before about how those angles match going all the way around? Okay, so, all right, so let's see. This one was 30 or pi over 6, right? And the coordinates were, let's see, cosine and then sine, right? So what was the cosine of 30 degrees? Let's see. I believe that's the square root of 3 over 2. And the sine of that, oh, look, there was 1/2. Okay? And so then this would be pi over 4, which is 45, and that's 60, which is pi over 3. And you had the measurements. And we also talked specifically about how, you know, this is the x and this is the y, that this 30 degrees was the same thing as this one over here, which was 150, and I think it was like 5 pi over 6. These match, right? Your coordinates over there are the exact same, only the x is now negative root 3 over 2, and that's positive 1/2. Okay, so those are your two places on the unit circle that actually have a sine value of 1/2. Okay, so we have two different ways that we can answer this question. If you are being asked to find degrees, then this is what they're going to tell you. Find the x's basically that are between 0 and 360. And in that case, my answers would be 30 degrees and 150 degrees. Okay, but we can also ask for this in radians. And that's what that means. I'm looking for a radian measure of an answer to this equation. So in radians, where does sine equal 1/2? Okay, well that's pi over 6 and 5 pi over 6. But again, you will need your unit circles, all three of them, because you will need to know the coordinates that go with the radians that go with the degrees. Okay, so let's try a couple more examples. All right, so same thing. Cosine of x equals square root of 2 over 2. All right, so we do the inverse on both sides, just like we did before. Okay, so x equals the inverse cosine of root 2 over 2. All right, so where on the unit circle does the cosine equal root 2 over 2? And we're looking for specifically the degree measures. Okay, so you look on your unit circle, and remember that the cosine is your x value, right? It's of your coordinates. Remember, it's cosine and then sine. Okay, so where on the unit circle does cosine equal square root of 2 over 2? Well, it equals it at 45 degrees and 315 degrees. And again, you should be using your unit circle to figure this out. All right, we're going to again ask for this in degrees. Okay, and again, show the work. You are doing the inverse sine on both sides. So x is equal to the sine inverse of 1. All right, so again, where on the unit circle does sine, which is your y value, equal 1 in degrees? At 90. And that's the only answer to that one. When we have things that fall on the axes, a lot of the times it's just going to be one answer. The ones that fall on actual measurements are going to have two, because there are two places on the unit circle where the cosine of root 2 over 2 is going to equal, or the cosine of something is rather going to equal root 2 over 2. And it's going to be a positive root 2 over 2. All right, let's try a negative one. And this time we're going to ask for this in radians. Okay, so same thing. We're going to take the inverse on both sides. Okay, so, and again, it's asking the same question. Where on the unit circle does cosine have a value of -1/2? And again, as a reminder for yourself and for me, your cosine is your x value. Okay, so where does cosine have a value of -1/2? That's 7 pi over 6 and 11 pi over 6. At least I think. Wait a minute, I think I may have got that wrong. Nope, nope. It's a 3 value, not a 6 value. Silly me. Because that corresponds in quadrant 1 to pi over 3. So that's pi over 3 to, oh, yep, 4 pi over 3 and 5 pi over 3. Oop, almost got it wrong. Okay, so again, sorry about that. X value has to be in both of the lower quadrants in order to be negative, right? And yep, cosine of half is at pi over 3. So it has to be the two angles on the bottom that have a 3 in the denominator. And I will teach you a trick on how to work with that, along with, using your unit circle. But I will show you a trick when we get back from spring break on how to try and remember that. Okay, so your assignment, and I want you to do this in class, and this really shouldn't take you more than about 15 minutes, if that, because then you'll have time to work on your journal or your project or anything else that you're missing, because your cutoff time for your classwork is coming up, as far as when it all needs to be done, or when it's going to be zeros and you can't do anything about it. Okay, it's in section 5.5. It's only 5 problems. I want you to send it to me through Remind, please. And then I want you to work on your project or your journal or your missing work. Now, as a reminder, I'm going to check your journal when you get back from spring break. and these are the problems I'm going to be checking. So if you have your journal, then go ahead and get it out. Okay, and I'll show you what I'm talking about when I have all these problems. So if you want to take a picture or, you know, whatever from the video, I'll show you exactly what problems that these are that I'm talking about, because it is quite a few. This is pretty close to half your journal you should have actually been able to do by now that we've learned how to solve. Okay, so I'm going to show you what these problems are. All right, just so that you understand. I think, if I'm not mistaken, it is on the first page. You should have all of these two columns done. Don't worry about the tangent. We're going to get to that when we get back from spring break. So you should be able to get both of those columns. That's all the 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, all that kind of stuff. Okay, you should be able to answer both of these, sine and cosine. You should be able to do all of your conversions to radians. Believe it or not, you should actually be able to do both of these columns now, because what they're asking you for is what we just got finished doing. Where does sine equal a half? Where does cosine equal a half? You should be able to do all your radians to degrees conversions. That takes us all the way to, oh look at that, 51. Okay, then you should be able to do 52. And again, don't worry about tangent, we're going to do that when you get back. 54, 56, and 57. You should be able to do all of those graphs. The only other thing that you should be able to do, besides basically most of these first few pages, is the trig word problem. And the trig word problem I'm talking about is this one, where it talks about throughout the day the depth of the water. Okay, and it has the times, and this is very, very similar to a question that was on your test, and very, very similar to questions that were in your homeworks. Don't worry about the C, we don't do that. So, but you should be able to write the equation, and you should be able to plug in 9 a.m. and 3 p.m. since we're talking about midnight is time 0. And you should be able to solve that. So that's a good bit that you should actually be able to do. 3, 6, 9, 12, 13, 14, 21, 22, 23, 24, 25, 26, 27, 28, 29. I think that's another 7, so that's 36, 37, 38, 39, 40. You should be able to have done 41, which is almost half of your journal. And I'm going to be checking for these when you get back. Okay, that was the promise, that I would not assign you any extra homework as long as you got, we're actually working on your journal. So that being said, your project is due by midnight tonight. Every day that you turn it in late is minus 10%, and I'm not taking excuses as far as I thought I sent it, it didn't go through. I'm not taking excuses on this. You have email, and you have Remind, and you have Canvas. And if you're worried that it didn't go through, then don't wait until midnight and then send me a message and ask, did I get it? Send it at like 10 o'clock and then send me a message, did it come through? Okay, so no excuses. Every day late is 10% off. And for those of you who did well on your test, I guess it wouldn't hurt you very badly to do poorly on your project, but it will pull your test grade down because this is the other half of it. Okay, so April 9th, that's what you should be finished with as far as those 41 questions. All right, I will see you after spring break. Enjoy yourself, but don't slack off too much.